Hello students and welcome to the session. In this topic we are going to learn about how to calculate the concentration of a particular species at the equilibrium at that temperature. Let's begin with this. So let's begin with calculating equilibrium concentration, that how to get the equilibrium concentration when you are given the initial concentration and the value of the equilibrium constant. So how you will going to calculate, find out that what are the concentration of the reactant as well as the product at equilibrium. Fine. It is done by ICE method. ICE means initial concentration method. Initial concentration equilibrium constant. That should be known to you. Initial concentration and the value of equilibrium constant. We know that the equilibrium constant and the initial concentration, we can calculate the reactant concentration at equilibrium. So you need to keep this in mind and always follow the way of representation like that. Reactants, products, initial concentration, say something and something, change in the concentration, say minus x or minus x, obviously where x is a change in concentration. If minus x is there, product will be plus x. If product is minus x, reactant will be plus x, and therefore equilibrium. Okay, now let us see how to use this. Okay, suppose you have this reaction, atomization of bromine, molecular bromine reverses to give you atomic bromine. You know the temperature of it, okay, and the equilibrium constant, this much, 1.1 10 to the power of minus 3. So the concentration of bromine you know in molarity, okay, concentration of atomic bromine also you know in terms of molarity, but these are the initial concentration, not the equilibrium concentration. So you cannot put this in the Kc equation. You cannot put it. Why? Because these are initial concentration. Okay, so let us see how to solve these kinds of question. Okay, so let x be the change in the concentration of bromine. We all agree that the bromine's concentration will change. Okay, so let x be that change, that some amount of bromine will break into atomic bromine. So let x amount of bromine change. Therefore we will write this equation, initial concentration, change, equilibrium, that ICE method. So initial concentration is this much molar, which is where in the question. Okay, so change will be minus x, therefore the equilibrium concentration will be the initial minus x. The initial concentration of bromine will be this much, change will be obviously plus 2 times x. Why? Because the stoichiometric coefficient is 2. If you apply the stoichiometry law, x amount of minus here means 2x amount of addition here. Therefore the final will be this. Now you can use this concentration in your Kc expression. Okay, let's see. So the expression for Kc, we all know that it is this much. That means product, basically law of masses, action of mass. All I needed was to put the numerical data, which I put down, and the change, taking the change as x. Fine. Now I can solve for x. I have a quadratic in x, I can solve it. Okay, so this was what the quadratic we got, simplifying it to this, which means this is to be followed. Calculating, I got one value of x as this much minus and the other value of x as this much. Now both the value of x, if you look at first instant, will appear to be reasonable. Fine, x can change even that, x can also changes that much. Let us see what happens in this case. Okay, so I have two values of x earlier. Now let us see what will happen. So at equilibrium, the concentration of atomic bromine will be this much plus 2x. So if I use the value of x obtained earlier, I will get this much. And at equilibrium, concentration of molecular bromine is this much, which is this much, or this much, by using the second value of x. But can the concentration of bromine be negative? No, because concentration of bromine obviously cannot be negative. Concentration has to be positive or 0. The lowest that the concentration can get is 0, but not negative. Or this value which is obtained was obtained from the second value of x. which we had obtained by solving the quadratic. So we rejected that one. Okay, so that is how you are going to find the equilibrium concentration. Now let us see the points which you must keep in mind to get the equilibrium concentration. The first point should be express the equilibrium concentrations of all species in terms of initial concentration and a single unknown x, okay, which is basically the change in concentration, like we did in case of bromine. We made it plus 2x, means the atomic bromine was initial concentration plus 2x, while the molecular bromine was initial concentration minus x. Okay, now with this, the value of put that in the value of equilibrium expression constant, equate it, and then get a equation in x and solve for x. That's all you need to do. After solving for x, put that in the equilibrium concentration to get the equilibrium concentration of all the species. That's all you need to do, as simple as that. Okay, the only thing which you should remember is you must not make a silly mistake while solving for x. Okay, do not make silly mistakes. This is the most common mistake which people make while solving for x. Okay, so we have seen and deduced very important method, that is how to find the concentration of a particular species at a given temperature at equilibrium.